Here's the answers to the first three problems on the mole-to-mole problems. Please make sure that with all of your work, you've got the correct unit on the bottom so that those cancel out, and that the unit that you want to get to is on the top. So that way you make sure that you get the correct answer. So double check your answers for those first three. All right, for the last two on this page, number 4 is pretty straightforward. You're just setting up your mole-to-mole ratio and getting 20 moles. The next one is a little bit tough. It's kind of like figuring out your limiting reactant, just like we did with the s'mores. So you're given one material and you're given 6 moles of K3PO4. So your first step is to see how much KNO3 is made from that. And you get 18 moles of KNO3 is made from that. But we've got to look and see, well, what about the fact that I'm being given 2 moles of aluminum nitrate? How much of my product, KNO3, can I make from that? And I can only make 6 moles of KNO3 from that. So we look at this just like our s'mores lab that we did, and we look and say, okay, I can make 18 from 6 moles of this guy, and we can make 6 moles from 2 moles of this guy. So who's limiting me? Which one am I actually going to be able to make? Well, I don't have enough of aluminum nitrate to make 18 moles. I only have enough aluminum nitrate to make 6 moles. So that means I'm only going to be able to make 6 moles of material. So that means this right here, that's how many moles I will be able to make. And this guy is actually going to be limiting me then. He's going to be called our limiting reactant. Because if I had enough, this guy right here is our limiting reactant. If I had enough of aluminum nitrate to make 18 moles, then I'd make 18 moles because that's how much I can make with this guy. So I'm going to have excess of K3PO4. So make yourself a note of that. You're going to make 6 moles of product. This material right here, he's going to be called your limiting reactant. And this guy, K3PO4, we're going to have extra of. Here's our first problem for mass to mass. It says how many grams of potassium chloride are produced from 25 grams of potassium chlorate? Well, in order to get from one material to another, I have to be in moles to moles. So my first job is to take that potassium chlorate and divide it by the molar mass to find out how many moles I have. So I have 0.20 moles of potassium chlorate. Now I can use that in order to get to the other material. So I use my mole to mole ratio according to my balanced equation. So it says that I need 2 potassium chlorates, and from that I will produce 2 moles of potassium chloride. So it's a 2-to-2 ratio, so that means that I'm also going to be having that many moles of potassium chloride. But my problem wants to know how many grams. So I'm going to take that 0.20 moles of KCl and I'm going to find the molar mass. So 1 mole of KCl has a molar mass of 74.553 grams. And that's going to tell me then how many grams of KCl I have. So basically when I do this, I'm going to see that I'm starting with grams of A. I'm going to have to get to moles of A. I'm going to use my mole to mole ratio to get to moles of B. And then I'm going to use my molar mass of B to get to grams of B. So you should get an answer around 15.21 grams for this first problem. All right, let's take a look at number 2. It's asking me how many grams of hydrogen if I've got 50 grams of nitrogen. So this one's going to work the same way. I've got grams of A. I've got to first get it to moles of A, which is my first step here. Then once I've got moles of A, I'm going to use my mole to mole ratio to get to moles of B. Then once I've got my moles of B, I'm going to use my molar mass of B to get my grams of B. So here's what each of my steps looks like, and then finally I end up with 10.8 grams of H2 as an answer. Okay, for number 3, it wants to know now how many grams of ammonia will be produced. So I'm still starting with 50 grams of nitrogen, which means that I need to get to moles of that material. Then I'm going to use my mole to mole ratio to get to moles of ammonia. And then I can finally use the molar mass of ammonia to get to grams of ammonia. Pause it and try it on your own, and then take a look at my answer. So I went ahead and put all my steps together. Here's my step for getting from grams of nitrogen to moles of nitrogen. Here's my mole to mole ratio, and then here's my molar mass of ammonia in order to get 60.8 grams of ammonia. Next problem is going to work the same way. I'm given 5 grams of one material. I'm going to have to get that to moles of that material. Then I'm going to use the mole to mole ratio to get to moles of the other material, which is silver chloride. And then I'm going to use the molar mass to get to grams of that material. Go ahead and pause it and try it, and then check your work. So here's my work for that next problem. I'm starting with grams. I use my molar mass of that material to find out how many moles, mole to mole ratio, and then the molar mass of material B in order to get 4.2 grams of silver chloride as an answer. So the next problem says how much barium chloride is necessary to react with the silver nitrate in the previous problem. So in the previous problem, we've got 5 grams of silver nitrate, and this time we're going to find out barium chloride. So it's going to be the same steps that we've been doing. We're going from grams of A to moles of A. Then we're going to use our mole to mole ratio to get to moles of barium chloride. And then we're going to use the molar mass of that guy, barium chloride, to find out how many grams of barium chloride that's going to make. So pause it, try it, and then check your answer. So here's my answer for that last problem. Starting with 5 grams of silver nitrate, divide by the molar mass, multiply by the mole to mole ratio, multiply by the molar mass of barium chloride to get 2.6 grams of barium chloride. All right, let's look at some mixed stoichiometry problems